Welcome back. If you're joining us today, you're probably a fellow curious mind. Someone who loves pulling back the curtain on how the world actually works.
Right, especially when it directly impacts your wallet.
Oh, exactly. And today, we are doing a deep dive into a scenario that might hit, well, incredibly close to home.
Yeah, it's a very real situation for a lot of people right now.
So I want you to picture this. It's the dead of summer, 2026. The heat is just absolutely radiating off your driveway.
The worst kind of heat.
Yeah, and your air conditioner just breathed its last agonizing breath. So you decide it's finally time to pull the trigger on a replacement.
You have to, you can't just sweat it out.
Right. And you actually get a quote for an identical AC unit from your local contractor back in the summer of 2024.
Oh, so you've got a baseline.
Exactly. You still have the paperwork sitting on your fridge.
Oh.
That price, 2 years ago, was $7,400.
Which is, a relatable position to be in. You figure, well, maybe with a little inflation, it's going to be, what, like 8,000?
Right. That's the logical assumption. So you call the contractor up, they come out, run some numbers, and they hand you the updated 2026 quote.
And here comes the pain.
Oh, yeah.
Yeah.
The new price, $9,200.
Wow.
Yeah. That is a massive 24% jump for what looks like the exact same metal box sitting outside your house.
As a homeowner, your first instinct is just pure, unadulterated rage.
Or 100%. You immediately assume the contractor is just price gouging you.
Which is entirely fair. Look, a 24% increase on a standard residential system in just 24 months, that does not feel like normal market inflation.
No, it feels like opportunistic markup.
Exactly. But for our deep dive today, we're going to look at the hard evidence. We've brought in a really fascinating stack of source material.
Yeah, specifically, we've got the detailed operating notes from Dave Hartzell.
Right. He's a master HVAC veteran with 45 years in the trade. He runs an independent shop out of Kingfisher, Oklahoma.
And he is the actual contractor who wrote that exact $9,200 quote.
Okay, let's unpack this, because our mission today isn't to defend just some random price hike.
No, it's to track every single dollar of that $1,800 difference.
Right. And what Dave's notes reveal is that you aren't paying a sneaky markup. You are paying for a massive industry-wide regulatory earthquake.
It's basically a top-to-bottom redesign of the equipment.
Yeah, a literal change in the chemical fuel running the machines and a total overhaul of the local mechanics toolkit.
And it was all compressed into a single 12-month window.
It's wild. To understand the price tag on that outside box, we have to start by looking at the chemical blood pumping through its veins.
Refrigerant.
Exactly. The entire HVAC industry has always been defined by its refrigerants. If we go back a couple of decades, almost every home AC unit ran on a chemical called R22.
Right, which was cheap and cooled your house beautifully.
It did. But R22 had a massive environmental target on its back.
Because it was literally eating a hole in the Earth's ozone layer.
Right, that was the fatal flaw. So global treaties were signed, R22 was phased out, and the industry scrambled to find a replacement.
And they landed on a new chemical standard, right, R410A.
Right. Yep. From roughly 2010 all the way to 2024, R410A was the undisputed king of residential air conditioning.
It was hailed as a savior because it had an ozone depletion potential of absolute zero.
Right, but, as we often see when we try to engineer our way out of a crisis, solving one massive problem can inadvertently create another.
Yeah, R410A saved the ozone layer, but we soon realized it had a staggering global warming potential, or GWP.
It's huge. Dave's notes put the GWP of R410A at 2088.
2088.
Yeah. Let's contextualize that number, because GWP is a measure of how much heat a greenhouse gas traps in the atmosphere compared to carbon dioxide.
Okay.
So a GWP of 2088 means that if 1 pound of R410A leaks out of your air conditioner into the sky, it traps 2,088 times more heat than a pound of CO2.
Which is an astronomical climate footprint for a single household appliance.
Exactly. And that brings us to the regulatory hammer. The EPA passed the A Act of 2020.
Okay, so this is the legislation that drew a line in the sand.
Right. It capped the allowable GWP for refrigerants used in new residential AC units at 700.
And the deadline for that cap was January 1st, 2025.
Yeah. With R410A sitting way up there at 2088, it instantly became mathematically illegal to use in new systems.
So the entire manufacturing sector basically had to pivot to new chemicals to meet that 700 limit.
Right.
It reminds me a lot of the shift from leaded to unleaded gasoline in cars, We realized the fuel we relied on was fundamentally toxic to the environment, so we mandated a new fuel.
That's a great comparison.
But a new fuel means you have to redesign the engines to burn it. But before we get into those new machines, I kind of have to push back a little here.
Okay, go for it.
If R410A was such a potent greenhouse gas, why did the smartest engineers in the world rush to make it the global standard back in 2010?
Well, it comes down to the brutal reality of crisis management.
Who do you mean?
When the mandate came down to save the ozone layer, the chemical industry didn't have, decades to perfect a flawless replacement.
Right.
They needed a chemical that wouldn't destroy the ozone, but could still handle the intense pressure and thermodynamics required to cool a house.
So R410A was basically the miracle cure for the immediate emergency.
Exactly. The greenhouse gas properties were known by scientists at the time, but the ozone hole was the fire burning in the kitchen.
That makes sense. But now, a decade and a half later, the bill for that greenhouse gas potential has come due.
Yep.
So if R410A is out, what are the new chemicals stepping into the ring for 2026?
So the manufacturing world essentially split into two competing camps.
Okay.
Major brands like Trane, Amana, Carrier, and Lennox adopted a refrigerant called R454B. It has a GWP of 466, so it's safely under that 700 limit.
Right. And the other camp.
On the other side, companies like Daikin and Mitsubishi went with R32, which sits just under the wire with a GWP of 675.
Okay, I want to pause and just reassure everyone listening right now who might be glancing nervously at the AC unit sitting outside their window.
Yeah, don't panic.
Right. If your current system uses the old R410A like, millions of units sitting on slabs across Oklahoma and the rest of the country, you are not breaking the law.
That distinction is critical. The EPA is not deploying task forces to confiscate your air conditioner.
Thankfully.
Existing systems are perfectly legal to operate. The regulation dictates that you simply cannot buy or install a new R410A system starting in 2026.
So the new units rolling off the factory floors must use the new refrigerants.
Exactly. Which triggers an incredible engineering domino effect.
Right, because as Dave Hartzell's notes emphasize, both R454B and R32 share a specific chemical classification.
Yeah, they belong to the A2L class of refrigerants.
And that tiny alphanumeric code A2L is the hinge this entire price increase swings on.
It really is. A2L is an industry designation meaning mildly flammable.
Mildly flammable.
Right. The old standard R410A was an A1 class, meaning it was completely non-flammable under normal conditions.
Wait, let's stop right there. Mildly flammable.
Yeah.
You're telling me the government mandated that I put a flammable gas box next to my bedroom window.
I know how it sounds.
How is any homeowner supposed to feel safe with that pumping through their walls?
What's fascinating here is the sheer scale of the engineering response to that exact psychological and physical concern.
Okay.
First, we need to demystify mildly flammable. We aren't talking about something pyrophoric, meaning it doesn't spontaneously burst into flames the second it touches air.
That's a relief.
Right. Nor is it explosive like propane. A2L chemicals are actually incredibly stubborn.
Stubborn hell.
To ignite them, you need a massive, sustained leak in a very confined space, combined with a highly active, continuous ignition source, like an open flame.
So it's a low probability, but, in engineering, a risk greater than zero requires a safety net.
Precisely. Because the risk exists, manufacturers couldn't just pour the new mildly flammable chemical into the old machine designs.
Right.
They had to rebuild the safety infrastructure from the ground up, relying on a concept called the lower flammability limit.
So how does this new infrastructure actually prevent a fire in my house?
Okay, so every single new R454B or R32 system now features a highly calibrated refrigerant leak sensor built directly into the indoor air handler.
The part of the system usually sitting in your closet or your attic.
Exactly. If that sensor detects even a trace microscopic amount of leaked refrigerant, it instantly triggers your system's main blower fan to turn on at full speed.
Wow. That is actually a brilliant mechanical failsafe.
It is, yeah.
It's like when you accidentally burn toast in the kitchen. If you leave the doors closed, the smoke detector blares and the room just fills with smoke.
Right.
But if you immediately turn on the ceiling fan and open a window, the smoke disperses so fast it barely even registers.
That is the perfect analogy. The fan rapidly circulates the air through your home's ductwork, diluting the leaked gas so heavily and so quickly that it can never physically reach that lower flammability limit.
Because the gas is constantly being dispersed by the fan.
Right. It cannot pool together densely enough to ignite, even if you struck a match.
But engineering that failsafe into every single unit isn't cheap.
No, it's not.
And Dave's notes outline a laundry list of other hardware changes too.
Oh yeah, it goes way beyond just the sensor.
Right, because the new chemicals run at slightly different pressures and thermodynamic properties.
So manufacturers had to redesign the service ports to prevent technicians from accidentally mixing old and new chemicals.
Which makes sense.
And they had to resize the internal metering devices that control the flow of the gas. They even had to invent entirely new brazing alloys.
Wait, brazing alloys?
Yeah, the metal used to weld the copper joints together. They had to invent new ones to handle the specific vibrations and pressures of A2L refrigerants.
Wow. The manufacturers basically spent 2 entire years locked in research and development just to accommodate this A2L class.
Exactly. And by the time these redesigned sensor-equipped units leave the factory floor, their base manufacturing cost is already 8 to 12% higher than the old models.
But the financial shockwave doesn't stop at the factory loading dock.
Right.
We have to look at the local contractor's burden.
Right.
It wasn't just massive corporations like Trane or Lennox that had to adapt. Dave Hartzell and his crew, the folks actually driving the trucks to your house, they had to completely reinvent how they do their jobs.
The tooling overhaul on the contractor side is arguably the most staggering part of this whole transition.
Really?
Yeah. Because A2L refrigerants are mildly flammable, almost all the specialized tools used for the old non-flammable R410A became instantly obsolete, or frankly, unsafe.
Right. And Dave's shop had to spend $14,000 in a single year just to upgrade their trucks to legally install the new systems.
Yep.
14 grand. Just for the privilege of keeping their business open. What specifically are they buying that costs so much?
It's highly specialized safety gear. For instance, they had to buy brand new A2L rated recovery machines.
Okay.
The old machines had standard brush motors that could occasionally throw like a microscopic internal spark.
Oh, and with non-flammable gas, who cares?
Exactly. But with A2L gas, a spark is a massive liability, so they need new spark-free recovery units.
Makes sense.
They also need specific vacuum pumps that use a completely different type of synthetic oil because A2L chemicals interact poorly with legacy oils and can actually gum up the machinery.
Wow.
Add in highly sensitive new leak detectors, new pressure gauges, new brazing setups. I mean, the receipt gets long incredibly fast.
And Dave's notes highlight a massive logistical nightmare for the trucks themselves, too.
Oh, the inventory issue.
Yeah, because it's 2026. A contractor's day is split. In the morning, they might go service an older R410A system across town.
Right.
But in the afternoon, they drive to your house to install a brand new R454B system.
So their truck inventory practically doubled overnight.
Exactly. They have to carry duplicate copper fittings, duplicate chemical tanks, duplicate tools, just to prevent cross-contamination.
And we can't forget the training. Every single technician in his shop had to undergo mandatory NATE recertification.
Nate.
Yeah, NATE stands for North American Technician Excellence. It's a premier industry credential.
Okay.
And on top of that, they had to update their EPA Section 608 licenses.
Which is the federal certification required to legally handle refrigerants, right?
Correct. They essentially had to go back to school to learn how to manage these new A2L flammability protocols.
Okay, let me put myself in the homeowner's shoes for a second.
Sure.
I completely understand that Dave had to buy new spark-free vacuum pumps and, take a few classes.
Right.
But why am I footing the bill for the mechanic's wrenches? I mean, if I take my car to the local auto shop, I'm paying for the new brake pads and the labor, not the hydraulic lift they put the car on.
It is a totally valid frustration, but it really reveals the brutal reality of small business overhead.
How so?
That $14,000 in mandatory new equipment isn't a one-time luxury purchase for a contractor. It is a strict regulatory cost of doing business.
Right.
An independent local shop simply does not have the profit margins to just absorb a massive mandated capital expenditure out of pocket.
So they have to pass it on.
In the business world, that overhead has to be mathematically amortized. It gets sliced up and spread across the labor and operational margins of every new install quote they write.
Here's where it gets really interesting, because now we can take all of these abstract concepts, the EPA caps, the mildly flammable chemistry, the factory sensors, and the contractor's new spark-free tools, and map them directly onto the actual math on your receipt.
Let's look at Dave's notes and break down exactly where that $1,800 increase came from.
To set the baseline, we are comparing the exact same equipment tier. A 3-ton, single-stage AC paired with an 80% furnace.
Right. And just to translate that for everyone, 3-ton refers to the cooling capacity, roughly 36,000 BTUs. Single stage means the unit has one speed. It's either 100% on or 100% off. Got it. And the 80% furnace means it converts 80% of the natural gas it uses into actual heat for your home, while 20% is just lost as exhaust.
Right. And in 2024, that total package was $7,400.
Exactly. And in 2026, it hit $9,200.
So let's look at Dave's breakdown. The first bucket is $700.
Right. That is the pure equipment cost increase passed down from the manufacturer to cover all the R&D, the new coils, and those internal redesigns we discussed.
Okay, so $700 to the factory. Then Dave outlines another $400 for new line set requirements and the specialized A2L copper fittings needed to pipe the mildly flammable gas from the outside unit to the inside unit safely.
Yep. Then you have a $200 bucket that goes directly to the physical cost of that indoor leak sensor system we talked about.
Right, including the complex low-voltage wiring required to tie it into your blower fan for that fail-safe dilution. And we can't ignore the macroeconomy here. Dave attributes $300 to lingering 2025 supply chain and freight increases,
which drove up the cost of logistics and heavy building materials across the board.
And the final $200 bucket is extra labor.
Right. Because of the strict new safety protocols for purging lines and handling A2L refrigerants, the installation process physically takes a technician about an extra hour to complete compared to the old R410A days.
So you add all that up. $700 for the factory, $400 for the piping, $200 for the sensors, $300 for freight, and $200 for the extra hour of labor.
And there is your $1,800.
It is not a greedy markup. It is literally an itemized receipt of regulatory compliance.
Exactly. And if we connect this to the bigger picture, there is actually a genuine silver lining for the homeowner.
Oh.
The upfront sting is very real, but the day-to-day running costs are favorable.
Favorable.
Well, that is because the new R454B chemical is significantly more thermodynamically efficient than the old stuff. Pound for pound, it is about 7% better at moving heat out of your house.
Meaning it uses less electricity to do the exact same job.
Exactly. When you look at the yellow Energy Guide sticker on the side of the unit, it measures the CR2 rating, the seasonal energy efficiency ratio.
Right. A higher number means it's more efficient.
Because of the better chemical, a 16 CR2 unit installed in 2026 will cost you the exact same, or perhaps even slightly less, on your monthly utility bill than a 16 CR2 unit from 2024.
So the pain of this transition is fiercely concentrated at the point of sale, but your monthly utility bill remains honest and stable.
Yep.
But because that point of sale pain is so intense, homeowners are frantically Googling for financial relief.
Oh, constantly.
And that desperation leads directly into a massive pitfall in the 2026 market, a total epidemic of bad information regarding tax credits.
Yeah. This is where, as a consumer, you have to be so vigilant. Because if you drive down the highway or sit at a kitchen table with a less scrupulous contractor,
you are going to hear grand promises of federal tax credits designed to offset the cost of these new efficient systems.
But Dave Hartzell's notes make this crystal clear. Those federal tax credits are completely gone. Gone. Section 25C, which used to offer a 30% credit up to $2,000 on heat pumps, expired on December 31st, 2025.
Wow.
And Section 25D for geothermal systems also expired. They were wiped out in the 2025 congressional budget reconciliation.
So if I see a billboard right now in 2026 advertising a massive federal tax credit for a new AC, what is my move?
You write down the name of that company and you make sure never to call them.
That bad.
You have to view marketing in a transition year through a highly critical lens. If a contractor is using expired federal promises to soften the blow of a $9,200 quote, they are either dangerously misinformed about the tax code or they are intentionally misleading you.
And basing your household budget on a ghost credit will be a devastating surprise when you file your taxes next April.
Absolutely.
So where does the actual financial relief come from in 2026? Dave's notes provide a brilliant case study using local utility rebates in Oklahoma.
Right. Local utility companies are stepping into the void left by the federal government because they have a vested interest in grid efficiency.
Okay, break that down for us.
Well, during a 100-degree summer day, the power grid is strained to its absolute limit. It is actually cheaper for a utility company to pay you a rebate to install a highly efficient AC unit than it is for them to spend billions building a new power plant to handle the peak load.
Oh, that makes total sense. They are subsidizing your efficiency to save themselves money.
Exactly.
And Dave lists some incredible local numbers. For example, OGE pays between $1,500 and $3,000 for qualifying high-efficiency air conditioners.
That's massive.
OEC pays $200 to $325 per ton for high efficiency and up to $700 per ton if you go geothermal. Cimarron Electric is paying a flat $600, and Seek Energy offers a massive $2,000 per ton for geothermal installs.
Though Dave does note a huge caveat there, right?
Yeah, that specific rebate is restricted by county, and his clients in Kingfisher County aren't actually eligible for it.
And that nuance right there is the true value of an experienced local professional.
Totally.
If you stack those local utility rebates, homeowner in central Oklahoma can expect anywhere from $1,200 to $3,500 back.
Which effectively wipes out the $1,800 regulatory price bump we just mapped out.
But, and this is a big but, you only get that money if your contractor understands the hyper-local grid rules and actually submits the complex paperwork on your behalf.
So what does this all mean for you, the listener? We've covered the EPA mandates, the A2L chemistry, the $1,800 math, and the utility grid incentives. But we need to leave you with a practical game plan.
Right.
If your AC starts making a horrific grinding sound tomorrow morning, what is your decision tree?
It entirely dictates on the current age of your equipment. Let's break it down into 3 windows.
Okay, with me.
If your AC is between 0 and 8 years old, the answer is incredibly simple. Repair it.
Just repair it.
Yeah. Even though you cannot buy a new R410A system, the chemical itself is still being manufactured in smaller batches, specifically to service existing units.
So if you have a relatively young system and a part fails, replacing the part is unequivocally the smart financial move.
Exactly.
What if the unit is sitting in that 9 to 12-year window?
That is the gray area. If it's a minor electrical fix, like a blown capacitor, repair it and keep it running.
Right.
But if it is a major catastrophic failure, like a ruptured coil dumping refrigerant or a dead compressor, you need to ask your contractor to run 2 separate quotes.
One to patch the old unit and one to replace it completely with a new R454B system.
Right. You have to weigh the immediate cost of the repair against the long-term utility savings of the new technology.
Okay, but what if your unit is a teenager? What if it's 13 years or older?
In that scenario, you replace it.
Just replaced it.
The supply of virgin R410A is going to drastically tighten over the next 5 years as the EPA phase down accelerates.
Right.
By the time we hit 2030, the cost to get a simple R410A refrigerant top-off is going to be astronomical. Dave Hartzell specifically uses the word ugly to describe the future pricing.
Yeah, you do not want to be pouring incredibly expensive phased-out chemicals into a deteriorating 15-year-old machine.
Definitely not.
But Dave also drops a brilliant piece of insider advice for folks with older systems that are, still chugging along.
Oh, this is my favorite part of his notes.
He says, if your old unit is running fine right now, wait.
Wait.
Do not rush out to replace it today just to beat some imaginary regulatory deadline. Let the new 2026 R454B technology mature in the field.
Because like any brand new hardware generation, there are going to be quirks and bugs.
Exactly. Let the manufacturers iron those out in years 2 and 3. Target 2028 for a replacement if you have the luxury of time.
But obviously, if your unit is dead and it's 100 degrees outside, you replace it today.
Right.
This raises an important question about how we interact with regulations. A government timeline should never dictate your personal home economics.
The EPA's calendar is not your household budget's calendar.
Precisely. The right decision for your home depends entirely on the mechanical health of the metal box in your backyard, not the year stamped on a piece of legislation.
We started this deep dive exploring the rage of a homeowner, convinced they were the victim of a local scam.
And rightfully so, on the surface.
But once we actually looked at the source material, we uncovered a massive interconnected web of environmental mandates, a global shift to mildly flammable chemistry, redesigned safety sensors, and the absolute necessity of utility grid incentives.
The sticker shock of a $9,200 quote is a very tough pill to swallow. But as Dave's math proves, it is fundamentally honest.
Yeah.
It is an accurate reflection of the true cost of bringing an entirely new generation of environmentally compliant, mechanically safe technology into your home.
And for you, the listener, your best defense against feeling ripped off is curiosity. When it comes to your wallet, Ask the questions.
Demand the itemized quote.
Yes. Ask your contractor exactly what is driving the cost, verify the local utility rebates, and make sure they are doing the paperwork.
Before we sign off, I want to leave you with one final, lingering thought to mull over, which builds on everything we've discussed today.
Okay, let's hear it.
We know that the production of new virgin R410A is being systematically choked off by the government, and that by 2030, prices for a simple chemical top-off will be absurdly high.
Right.
So what is going to happen to all the millions of pounds of old R410A currently circulating inside the units running across the country today?
That's a good question.
Are we going to see the rise of a high...
That is a wild economic mystery to leave off on.
Yeah.
I mean, the future of neighborhood HVAC repair might look a lot more like a commodity trading floor.
It really might.
Well, thank you so much for joining us on this deep dive. Hopefully, the next time you walk past that humming metal box outside your house, you see the incredibly complex world operating right underneath the fan blades. Stay cool out there.